And thank you, Blanca, for that introduction, and a big thank you to everybody for being here. My name is Jeremy Ruston, and as Blanca says, you may know me from my work on an open source project called TiddlyWiki, which is 20 years old this year, but I'm actually only going to talk about that tangentially and leave this here to whet your appetite. I hope instead today to take you on a journey back to the very early days of home computers in the UK and use my experiences then to help us think about the landscape that we see around us today and the challenges that we face for the future. We'll talk about technology, but also culture and communities, and we'll hear a little from the young man on the left, and we'll be seeing some extremely fruity old 1980s computer animations. But I should perhaps first apologize to people who might feel strongly about other home computers, and there were many other fine home computers in the 80s. I'm not denigrating those at all. And perhaps a machine like the Spectrum might have had more influence on the games industry than the BBC Micro. But I would argue that the BBC Micro was unique in its influence on the broader computer industry. And of course, I wasn't one of the pioneers who built these machines, or built that generation of hardware and software. QCon has already been lucky enough to hear from some of those people, such as Sophie Wilson, and I highly recommend those talks. I was just an enthusiast, a fan, if you like, in the right place at the right time. So let's step into this handy TARDIS and go back to January the 30th, 1983.
In Southeastern 6 tonight, mastering the microchip, how two teenagers' expertise with computers is making them a fortune.
Now, you don't need a computer to tell you that we're now living in the age of the microchip. Our homes are rapidly being invaded by mini computers. 17-year-old Jeremy Ruston, Alex Goller, who's 15, are two London schoolboys who stand to make about £16,000 between them this year, cashing in on the computer craze.
So, strip away the prurient interest in money, God knows about that, and the focus on our ages, but that little news slot actually quite neatly shows how computers sat in the culture of that time. There was excitement about them, and that was newsworthy, but really just as I was there as a curiosity. Computers were new and exotic, vaguely threatening things that, to be honest, the vast majority of people at that time would never even have knowingly laid eyes on. In fact, at that kind of time, my parents would bring their friends up to my bedroom, or hacker space, as we'd call it today, just to marvel at the sight of a computer, rather as people in the 20s marveled at the sight of airplanes passing overhead. But the thing I love is that now those people are all addicted to their iPads. And I think the interviewer talking about computers invading our homes is incredibly revealing. I didn't have to be very astute at that age to realize that the problem was that he was scared of computers and the change that it represents. So that's my attempt to make a scary BBC Micro roaring. So I found that really weird at the time. How could anyone be scared of computers? They were self-evidently wonderful, fulfilling things. And since then, I've worked for many organizations that face threatening existential change, and discovered that, sadly, for many individuals within those organizations, the best strategy faced with a catastrophic change is just to ignore it and pretend it's not happening. So, for instance, at BT, I remember senior people who professed to believe that voice over IP wouldn't be a threat to BT's core business because customers, you, instinctively prefer the familiar, reliable feel of a landline call. And they believed that given a choice, that's what people would choose. So let's go back to 1983 and see how Jeremy responds to this impertinence.
Well, Jeremy, first of all, how did you become hooked, and what's the fascination?
Well, I started off being interested in electronics and building radios and so on. Then I started building small computers, and then from then I just started buying ready-built ones instead.
And here, indeed, is that first computer. Its chief advantage was that it was £39.95 in kit form, and probably on this screen you can see my cat-handed soldering, like, I don't know what that is. I was 12. Of course, it says there, I only had 256 bytes of RAM, but I don't think I ever filled that memory in my time with it. And astonishingly limited specification. As it says, no stack register. You know, it was like a RISC machine, a RISC processor that had been cut in half, then cut in half again, and then cobbled together to work. Incredibly hard to convey how hard it was to use. It was about as much fun as programming a central heating controller. But our expectations of 256 bytes of RAM can be wrong. This is an image that's it's an entry in a demo scene competition. The conditions of this competition are to write a MS-DOS exe in 256 bytes. That image is a 20 kilobyte JPEG generated by 256 bytes. How can 256 bytes contain an image as rich and complex as that? An astonishing achievement, but an extraordinary commonplace achievement today. But what if I told you that actually, if you run this code, let's see what happens. It's actually animated. So to me, it's stunning that in the amount of space that I might allocate to a comment at the top of a file, somebody can build an entire immersive world. I think that is in the category of impossible things that we need to believe before breakfast. Going back to the 80s, in the absence of the internet, the home computer community primarily manifested itself through computer magazines, and there were a lot of them, and I guess they were a big business. A weird thing is, besides providing a substrate for the community, computer magazines were also a software distribution mechanism. They were stuffed full of listings of programs that people were expected to type in for themselves. And I soon started sending them in because they got published. It was, at the time, quite easy to figure out what people liked and send in this code. It was my first experience of what happens in a community. And today, working in open source, I see the same thing. It's the cycle of copying from other people, modifying what they've done, sharing it within the community, typically within a platform. It's weird to me that my first experience of that community was built on a substrate of old media, magazines and books and so on. But it was still the same process that we see today. So that was the context for me when the BBC Micro appeared, fresh from using a machine with 256 bytes of RAM. The photo I showed at the beginning was at the front of the machine, but in fact, the underneath and the back are far more relevant to our discussion. You can see a large array of ports on the back and the front, mysterious ports, a bit easier to see on the schematic. The BBC Micro arrived with a very detailed manual that included circuit diagrams of the connectors, which makes me laugh to think of the iPhone coming with a circuit diagram. And you can see there's a stunning array of ports, ones that you would expect, like a cassette interface, but also a networking interface. In 1981, it was, as far as I know, one of the first networkable home computers. It had a video output that you could connect to your television, and indeed the videos that you're seeing today were recorded on VHS like that. But it also had a digital RGB output, and underneath you can see parallel interfaces for disk, printer, and unassigned user ports that could be used for a variety of things. So I jumped in and enjoyed all of that, and made my way from sending programs to magazines to writing books. And books at the time were also a software distribution mechanism. So we tried to do the same things with software, but we had to make do with the media at the time. I think these books today would just be a YouTube channel. You know, kids today do that kind of thing, or probably a Discord server. But we didn't have any choice, so at the time I was tapping out these books on an electric typewriter with my mum proofreading them. It's also weird to think that home computers were so popular that, as Blanca briefly mentioned, the book in the middle actually made it into the Sunday Times top 10 bestseller list for a couple of weeks, which is extraordinary for an incredibly arcane, confusing a very technical book. But I think what happened was that a lot of parents were buying the BBC Micro for their kids in the belief that it would help educate them for the coming invasion of computers. And they also picked up a copy of my book to reassure themselves that their child was going to be learning to program and not just playing games. Less gloriously, the book on the right got me sued by Acorn, but we'll come to that. Several of the books were translated into other languages, and it was actually really cool at the time to see the mechanism that the publishing industry, how quickly and efficiently they could do that. But the thing that surprised me was that the book you see in the middle is an American edition of one of my books, and even that needed translation. I'd used the word clever in the English sense. That was a clever thing to do. But that has a completely different connotation in North America, and so the translators quite rightly had changed it to the word smart, which I would never use in that context. But that experience underlined for me the way that unknowingly our own culture and geography can be a barrier to communication. And we need to pay attention to that. And I hopefully will try to show you why. We see this idea in open source projects like TiddlyWiki. It has, like many open source projects, a plug-in mechanism. So we have a common substrate, a universal core, and plugins are our mechanism for people to accommodate people's sometimes conflicting requirements. And we've architected it deliberately to be translatable. And what you can see here is what happens as I work on TiddlyWiki. I'll merge a PR that might include a change to the English translation. And then within an hour or two, Bram Chen will submit a PR with the matching changes for the Chinese translation. It's by far the highest quality translation we have and the most up to date. And quite often, he'll point out errors in what I've done or inconsistencies. And as you can see, this has been going on for 10 years. So I've had a 10-year relationship with Bram, but I've never met him. We can't really communicate except in Google Translate mediated broken English, and of course through the code. But the privilege for me is that I feel I have these talented people looking over my shoulder, helping me with my work. I feel as though I, like a lot of us here, are participating in a completely new way of working that we're going to see more of in the future. And it simply couldn't have happened just a few decades ago, the idea of collaborating so closely with somebody on the other side of the world. In fact, the Chinese community of TiddlyWiki is interesting in other ways too. The first thing is it's huge. It's based on Chinese message boards and an ecosystem of tools that I can't really see. It's kind of like dark matter, this community that I can't see directly, but I know about it from the members of that community who also participate in the English language community. And indeed, there's a small group of Chinese developers who are incredibly prolific and valued contributors to the project. What it means to me is that I haven't accidentally made a piece of software that represents me. I haven't accidentally made a piece of software that embodies the thinking of a middle-aged white man, but I have actually achieved the goal of making something that's universal enough to be used by people of any culture. And I think that is important for all of us in our work. So, what were those books about? And I think this is the first bit of code I've shown, isn't it? When I got the BBC Micro, I dived into it, trying to understand every aspect of the machine. Sort of thing that would be impossible now. Nobody could understand the inwardness of an iPhone. There's just too much going on. But it was possible for one brain to understand the entirety of the inside of the machine. I'm afraid a lot of that is gone now. But at the time, I knew what every memory location, hardware register, etc. was for, and I knew how to blow up your monitor by freaking the video chip. For me, I think the biggest impact of the BBC Micro was going from programming in machine code to an extremely, at the time, advanced, sophisticated, elegant, basic language with a built-in assembler so that I could still jump into assembler when needed. And I was fascinated by the way programs like BBC Basic were constructed by people with great skills, deep technical skills, But they were using those skills to empower people with less deep technical skills to do the same kind of thing. So to me, that's a kind of magic, to take your skills and empower people with less skills to pull them up behind you. So we live in a world today that's riddled with software. We've said that several ways this morning already. The software is eating the world, software is making the world. It's riddled with it. Dig into the ground anywhere, all you'll find is software. Every type of business now has to be a software business. And software developers like us are in a unique position. We're the people that can not only understand this world built of software, but also we know how to change it. So, and I didn't explain properly, that was me disassembling BBC Basic. So I did a lot of that. And in fact, that's still going on today. You'll find the BBC Micro community, there's members who'll publish a new disassembly of some popular game from the 80s, and it's kind of a big event. Armed with what I'd learned by disassembling BBC Basic, I went on to write many compilers and interpreters myself, and realized that's what I cared about, creating a tool that I could then watch other people build something with, empowering them to do something that they couldn't do previously. And I think you see a nice example here with TiddlyWiki. TiddlyWiki has wiki in the name, but it's not at all interested in the idea of being a single page that lots of people can edit, although it can do that if you configure it that way. What it's really rooted in is a much more fundamental idea of wikis, which is that they elevate linking to be part of the punctuation of writing, as opposed to tools that require you to dive into a sub-dialog box to set up a link. So TiddlyWiki takes that further with a rich Wikitext syntax that can express complex interactive applications. And the goal of that, the reason why we do it, creating yet another computer language, is to let domain experts create their own custom tools, rather than having to go through a cycle of trying to explain their unexplainable requirements to a developer and then the feedback cycle that results. So here what we see is an example of TiddlyWiki being used by an American high school teacher to develop a custom application for teaching volleyball. And I've no idea what it means. You click around, I'll post links to all this stuff, but you click around in it, there's masses of it. Little tables of instructions, ways of tracking the progress of the students. Now, the thing that's interesting to me about that is I don't believe this world at the moment has a viable business model for custom software for volleyball teachers. There's no business there, is there? How can we serve those people? We know that what we do is useful. We know that computers and software applied carefully can help jobs like that. We simply don't have a business model. So to me, the best that we can do is empower the people who have the domain skills to build their own software. We have to step around capitalism and focus on people's needs. Another example is TiddlyWiki being used by the Anna Freud Center. They're a London-based charity that do training and resources for working with young people with mental health problems in their families. They train all the social workers and similar people around the country. Now, the challenge for them is that they've got a team in London who are highly skilled, experienced, and they know about the evidence, based on evidence, what practices work when you're in that situation with troubled young people. So their approach is to build a manual telling people what to do. But the discovery very early on was that if a team in London put together a manual telling you what to do, and then you give it to the team in Dagenham, if the team in Dagenham see things in the manual that don't apply to them, they'll reject the whole thing. It's not for me. So what we do with TiddlyWiki at Anna Freud is build what they call a fractal manual, where there's a central manual, but individual teams get their own version of the manual that adds and removes content to make it relevant for them. Now, of course, that's easy, isn't it? It's just a database query, put different stuff on a web page. What's hard here is to build a model for doing that kind of task that these domain experts can do. So I'm not designing a system for you to use, I'm designing a system for social workers to use, for people whose skills are in another area. So let's, with that, step back to 1983 and have another patronizing question from our interviewer, and I'm afraid a slightly excruciating response.
It must be pretty difficult writing all these best-selling books and trying to struggle with your A-levels.
Yeah, it is actually very difficult. I failed my A-levels in the summer because of it, actually.
Has it all been worthwhile?
Oh yeah, very much so.
Now, of course, I wouldn't want to advertise the benefits of failing school, but at the time, all I was interested in was computers, and that was all I wanted to learn about. And back then, I didn't have any chance of learning about that at school. Instead, I learned from the community, well, and hanging around foils, reading all the important academic textbooks at the time. But now, of course, it's never been easier for people to educate themselves. We saw earlier those ports on the BBC Micro. They gave rise to an ecosystem of hardware that was really fun. I think the barriers to entry for that market were quite small. We saw a lot of innovative, strange hardware. This is a very early graphics tablet, which I had put to good use in some quite fun work, again, for the BBC. It was later in 1983, I think one of my favorite ever gigs, where I made a series of animations on the BBC Micro that were used with a voiceover to introduce children's BBC TV shows. It was a wonderful job. I would slouch into BBC TV Centre in the morning, have a meeting with the head of presentation, and we'd decide together that the next animation would be, say, a tin of sardines with a wiggly tail. And then I'd go back home, stay up all night with a pint glass of coffee, putting these animations together, and then slightly bleary-eyed, take them into the BBC the following day, and press the spacebar at the operative time for the animations to flow. And I was involved for a few years in this, but ultimately replaced by a broom cupboard, of all things. I'm watching these back now. I think actually the best thing about them is the sound effects. I hadn't kept these, obviously, and so I put out a Twitter alert and found that, again, there's a community that we didn't know about of people who collect old BBC and old British TV VHS tapes. And so I have managed to now scrape together about 8 of them, but there were a lot more of them originally. I also wanted to briefly mention the late Joe Armstrong. As Blanca mentioned, we'd been working together on a book about Tiddlywiki in just about a year before he died, almost exactly 5 years ago, in a week or two. Joe had first got in touch with me back in 2011, having somehow become, I'll say, obsessed with Tiddlywiki. We stayed in touch regularly and collaborated on a conference talk, and then the book, which was sadly curtailed when Joe passed. It was actually very difficult to get Joe to talk about his own work. I didn't have, at that time, any experience of Erlang, but I was fascinated to learn more. But every time I'd ask him a question, he would redirect it to some arcane intricacy of Tiddlywiki. And you can still see his blog today based on Tiddlywiki. Joe taught me the full implications of a really simple observation that I think really we're all grappling with. Latency matters. If you care about latency, you need to move computation to where it is needed. If you have separate bits of computation, the laws of physics pretty much mean that you're using the actor model. So I think Joe's formalization of the actor model into Erlang, to me, was a formalization of the laws of physics that I've found incredibly inspiring. But we'll go back to 1983 for not quite one last step.
Perhaps we could now take a look at your latest computer game, which is called Doctor Who, I believe. Now, how does this work? It's a sort of Pac-Man, isn't it?
Yeah, it's based on some of the ideas from Pac-Man, but it's a very long program. It's taken quite a long time to load off disk.
And it's going to pop up here. Here we are.
Yeah, essentially, you're that little dot in the corner.
Down here.
Yes, and you're being chased by those worms who have now eaten you. Which is the end of the game.
Oh, I see.
The game I showed was described as being called Doctor Who, but in fact it was a bit more than that. It was the BBC's first official computer game using their now cherished Doctor Who intellectual property, but I don't think it was quite so prized at the time. And you might think it was an eccentric decision to entrust a franchise like that to the hands of a 16-year-old, however precocious. And I know we've got people from the BBC here, and I'm about to talk about how the BBC worked in 1983. I'm pretty confident it doesn't work like this anymore. What actually happened is I'd co-written a book for BBC Publications first called The Book of Listings, again reminding us that a book was considered an efficient mechanism of software distribution at the time. Getting a book published means having lots of meetings. That's how the industry worked at the time. And I remember being quite often in the BBC Publications offices in Marylebone. And once I was there, anything could happen. I guess the lesson I learned is that people are lazy. One day, I was in the office and somebody said, "Jeremy, would you like to do some modelling?" And I really thought they meant plasticine or Meccano, but they actually meant this. And I ended up on the box of the BBC's robotic turtle add-on. So in that context, when they started exploring making a Doctor Who game, obviously I was the logical choice. And I was a massive Doctor Who fan, of course, still a child at the time. I was thrilled. Sadly, I wasn't really a games player. My interest in games, again, was diving into the tour de force programming that I saw, and I wasn't that interested in playing games. Sadly, I never got to meet any of the actors, of course, but did get to collaborate with the Radiophonic Workshop on the music and sound effects, and did go to a props warehouse where I saw an enormous pile of Cybermen body parts being prepared for an explosion. It's a coding conference. Let's look at the code. Now, one thing that's quite fun is you might think I had to dig through the attic and find some old disks to find the code, but no, of course, you just Google it and it's on the internet. It's all been collected together and pored over and analyzed by people with far more skills than me. But a couple of interesting details. I mentioned before how it mixes assembly language and BASIC together. And you might notice we essentially minified our own code back in the day. I'm afraid to tell you that the game was not an unqualified success. I think it suffered from being made by a committee, and a committee of people who were inexperienced, didn't really know what they're doing. That's not the recipe for success. I hope I had an excuse being 17. But even though the game could have been so much better, I'm happy to say it is actually still bringing great joy to people. There's a steady stream of YouTubers reviewing in it, and they revel in its hapless terribleness. And I particularly recommend there's two French people who watch it who have a species of hysterics that is quite infectious. So let's jump back to one last dip into that interview.
What are the practical applications really for home computers? What's one of the most useful things you can do with one in the home?
I think the most useful thing really is word processing for writing letters and so on. And then there are the less general applications like shopping lists and what I used to call cataloguing records and books.
So I answer earnestly that I used computers for cataloguing books and records and had, in fact, written more than one program for that task. But of course, I was far too distracted by the joys of programming to actually use it for its intended purpose. So instead, I'm going to talk about something that I think the interviewer would have firmly considered utterly impractical and stupid. And this gives me a chance to talk about AI and large language models, which I know we'll all be expecting. But what I'm actually going to show you is the smallest feasible language model. It's something that many of you will know as a Markov chain generator. I didn't know that at the time. It's a program I originally wrote for the BBC Micro, and what you see here is a more recent JavaScript version that's on the web and you can play with. And what it does, very familiar process, you give it a body of training data, it does some frequency calculations, and then it generates essentially random text that matches the same letter sequence distribution. So let's see if we can give it a try. So I've primed it with a list of all the tube stations in London. And this is what I remember doing with it in the 80s. And my friends and I found this hilarious. We've got a setting. And if we'll start with 2 letters. So what it's doing now is generating, it chooses the first 2 letters of the output text, and then chooses the next letter based on the frequency of all the different letters in the original text that follow those first 2 letters. And then it bumps along and does a bit more. So there's 2 letters here. So as it says, we get near gibberish, but recognizably English, and some of them, if you weren't from London, you might think could be a plausible tube station name. But if we crank it up to 3 letters, get slightly more plausible gibberish. And I think South Greathrow is not bad. Hyde Parking Bridge, not sure about Cockfoston. And so it goes. And if we crank it up a little bit further, we get to confusingly readable, where we'll see frequently, oh great, Farring Broadway, love it. Now, I say, we were 17. This stuff is funny, but we really found it hilarious. And I think the reason why we found it so funny is interesting and relevant to where we are now. I think it's because of the way, oh, sorry, how do I get this back over here? There we go. I think it's because our brains are desperate to find meaning. We're sense-making machines. We bring in senses to our brain, and then our brain makes a story to ourselves about what it's seen. What this kind of thing shows us is that our brains are so desperate to find meaning that we're like somebody, a narc for a con artist. We're perfectly primed to see intelligence and meaning where there is none. And the fact that it's so easy to see meaning in a simple statistical trick like this proves how our brains make us vulnerable. So we are going to have one last dip into the 1980s. I worked with Richard Dawkins, who's at the time was famous as the author of The Selfish Gene. And we worked together on the graphics for a couple of BBC Horizon documentaries. I worked with him on these illustrative animations, and they also let me make the end credits, which, again, seems crazy.
There has to be an initial critical number, a critical mass of mice strategies that have to get together before they can take off in the evolutionary sense. When 2 chiefs meet, we know there's no chance of cooperation.
Once again, digging through this old stuff, something I find amazing is that 8-bit pixelated aesthetic was so mainstream, and that plinky-plonky music, extraordinary. Working with Dawkins did have a huge impact on me. In the years before, as a teenager, I'd become what today you might call a techno-utopian optimist, which has negative connotations to me, priding myself on my rationality. And I was obsessively worried or wondering about the meaning of life. I guess we all are at that age. And by the time I met Dawkins, I'd pretty much convinced myself that he was right, that the purpose of life is to pass on your genes. And Dawkins was very kind and generous with his time, and I learned a lot from him. But what I actually learned, what I actually became convinced of, is there's a lot more to human life than passing on our genes. And I learned a lesson that I find still guides me every day. And it's this. It's surely that if life has a purpose, it is to love and be loved. I think we need to ground ourselves on that perspective if we're to realize the potential of global collaboration. The fact is, we find ourselves working alongside people sometimes who take different sides in a bitterly contested argument. Only love, compassion, and understanding will get us through. We can think that we're in the technology business, but actually, it's the people business. And people work together best through love. So to close, I hope you won't mind if I briefly advertise my services. You've all got fascinating technical challenges, and I'd love to help you. You can find me on the second floor after this talk, and I look forward to talking there. Thank you so much for your time and attention. I really appreciate it, and I hope you'll enjoy the brilliant speakers lined up for the rest of the conference. Thank you.